Welcome to Math 096, Lecture 31. Today we're going to start off by continuing section 5.4. Last time we talked about adding polynomials. Today we're going to start off by talking about subtracting polynomials. So as you look at example 2, you'll notice the directions are subtract, and then the subtraction problem is x plus 12 minus the polynomial x squared plus 5. Now, much like what we were seeing when we were doing the addition problems, we can do these subtraction problems in two different ways. We can combine like terms, or we can subtract using columns. So let's go ahead and do both of these techniques and see what we see. So in order to combine like terms, the first thing that you want to do on this problem is realize that when you write down a subtraction symbol like that, and then you have a polynomial in a set of parentheses after that subtraction, there's actually a number sitting between the subtraction symbol and the set of parentheses. And that number is a 1. Or, if I want to think about it in a slightly different way, I would say that there's a negative 1 sitting in front of that second set of parentheses. Once I realize that there's a negative 1 sitting in front of that set of parentheses, this goes back to things that we talked about earlier in the course. This is in fact a distribution problem. So I can take this negative 1 and distribute it through to the x squared and distribute it through to the positive 5. So when I do that, I'm going to have x plus 12, and then negative 1 times a positive x squared is going to be a negative x squared. And then negative 1 times positive 5 is going to be negative 5. So notice something that just happened. Every sign in my second polynomial just changed. Now that's an important piece to remember whenever you're doing these subtraction problems. If you start going through a subtraction problem and you haven't changed every sign in that second polynomial, that means that something didn't work. Something didn't happen that should have happened. Well, now that I have that then, I can go ahead and move forward with this subtraction problem. So again, in terms of combining like terms, I can move things around if I want to, so that everybody that looks like somebody else is next door to it, or I can just do it in my head. So as I look at these pieces, I notice that I have an x, but I don't have an x friend. I have an x squared, but I don't have an x squared friend. And then I have two constant terms. So the constant terms are really the only two that are like terms. Remember that if we have like terms, they have to be the same variable to the same power. So with that in mind then, I can go ahead and bring down the things that don't have any friends and combine the things that do have friends and see what the answer is. But while I'm doing this, remember last time we talked about the idea of polynomials being written in descending order? That is a nice tradition to follow. So I'm going to go ahead and follow that tradition when I write down my final answer. So the highest power of x that I see in this problem is this power of 2. So I'm going to start by writing down that negative x squared term. And then, again, my x doesn't have a friend, so he's just going to come down, and he's the next thing I'm going to write down because he has a power of 1. And then the final thing I'm going to write down is my constant term. I can add the 12 and the negative 5. 12 plus a negative 5 is going to be a positive 7. So there's my polynomial answer in descending order. Negative x squared plus x plus 7. But again, we're going to be talking about some items later in the semester where it's nice to be able to do this kind of problem using columns instead. So let's go ahead and check out how to do this same problem in the columnar fashion. So again, you start off by writing down your first polynomial. So we have the x plus 12. And this time, because we're doing a subtraction, I'm going to put the subtraction symbol way out here on the left. And then I'm going to write down my second polynomial. But remember one of the things that I said last time. You have to make sure that you are making all the columns so that the same power of x is hanging out in each one of these columns. So notice here I have an x squared. I don't want to put that x squared in the same column as this x to the first piece from my first polynomial because they don't have the same power. So in fact, I want to put this x squared next door in a whole new column. So I'm going to put the x squared right there in my first column. And then I don't have an x to the first power in my second polynomial, so I'm just going to leave a little bit of a gap here to say that I don't have an x to the first, and then I have a 5. And again, I want to make sure that that 5 is lined up in the same column as the constant from my first polynomial, so I'm going to put it all the way over here to the right. So now I have a subtraction problem sitting here. However, as you look at this subtraction problem, remember the warning that I gave you in the left-hand column. You have to make sure that every single sign on your second polynomial changes. If you don't do that, that means that you're not really doing a subtraction. So when I look at this, it's tempting for a lot of people to come in and they'll see that this subtraction symbol is in front of the x squared, and they'll subtract the x squared, but that's the only thing that they subtract. So when I do this kind of problem in terms of subtracting polynomials in columns, what I do is I think about it in terms of changing signs. So what I do is come in and say, let's change this from a subtraction problem into an addition problem. But in order to make that happen, if I change this into an addition problem, every single sign in my second polynomial has to change. So my x squared is now going to be negative. And I like to just put a circle around that negative just to say that's the new sign. Well, over here, we have a positive 5. That sign has to change as well. So I'm going to put a negative there as well. So now that I have this written as an addition problem and all the signs in the second polynomial have changed, I can go ahead and think about what's happening column by column. So in my first column, I don't have any x squared terms from my first polynomial, but I have a negative x squared from my second polynomial. Those are going to come together as a negative x squared. In my second column, I have an x from the first polynomial, but not the second, so that's just going to come down as a positive x. And then finally, I have a positive 12 and a negative 5. When I add those together, I'm going to get a positive 7. And as you compare the answer in the two columns, you're going to see once again that I have the same answer using either one of these techniques. But once again, you want to make sure you're comfortable with both techniques, because we're going to come back to this idea of subtracting things in columns later, and you want to make sure you're comfortable with that process.